Hello dear students, welcome to my channel. In this video, I am going to explain you about binary search algorithm. Binary, as the name suggests, we will divide our list into two parts and then we will search our desired element. The binary search algorithm is used in a sorted array. That means the array which we are using for our searching purpose should be already sorted. The order, that means the time complexity in this binary search, is O log n. Why? Because we are dividing our list into two parts. So it will make it more simpler to search it if you have a larger data set. Right? Next we can see there are some advantages and disadvantages. It is much faster algorithm, it is efficient obviously, and it is simple to understand. But there are some disadvantages also. If you compare it with linear search, so you will find it more complicated than linear search. Because in linear search, we just simply pick up each element and then we are comparing it with our desired data element. But here we have to first divide and then we have to find out in the which part we need to search our desired data element. So we have some comparison, from the middle element we are comparing our desired data element, and then we will find out from which list we are going to search our particular desired element. Next you can see it is a case of binary search is shown on the diagram where I want to search this seventh element, and when I have compared it, so first I have divided my list into half, and 1 2 5 6 these elements I have discarded, right? From middle up to the upper bound I have divided it into two parts. Then again I have divided it into two parts, and then I have found the particular desired element. So this is how we will follow the process in binary search algorithm. In next slide, this is binary algorithm. Okay, so I will explain this now. Step 1, low is equals to 0. That means the lower bound or LB. In some books it is written as LB. So don't get confused. Lower bound, that means the starting point of our array, or you can say the first element of our array. High means the highest point, or you can say the maximum index number in our array. So that is n minus 1. N is the total number of elements in our list. So if we have taken 0, so that means it will be n minus 1. While low is less than equals to high, that means lower bound is less than or equals to high, we have to repeat these steps. We will first calculate the mid, that means we will compare our desired element to the mid. So for this we require mid first. I will calculate mid, I will add low and high, then divided by 2. So it's the middle element I have got. Now I will compare our desired data element with, this is ELE is the desired data element, and I am comparing it with the mid, means the index number is mid and that particular value I am comparing. If we have found it, that means LOC, this is the location where I have found the desired data element. So I will return this particular data element, or you can say the particular location of our desired data element. Now no need to repeat the steps as we have found our desired data element. But if we have not found, so what we have to do, we have to follow some other step. If the element is less than the middle, right? Less than means the element is small. So what we have to do, we have to break our list, and the highest element we will just shift that particular value to the middle. That means the higher values we are going to discard. We will not search in that higher part because our data element, the desired data element, is smaller than mid. Similarly, if our desired data element is higher value, then mid, then the lowest value we will discard and we will search in the highest values. In the last, if LOC is greater than equals to 0, that means we have found something. We have found a desired element. So that's why I have found here LOC, and I will search element found at location and I will print the value of LOC. Otherwise, that means we have not found, so search element not found. Isn't it very simple? Next, we will see the application of binary search with the help of Python programming language. Here, I have defined a function def binary search where I am passing an array, a desired data element which is x, low is the lowest point of our array or the first element of the array, and the high is the last element of our array which I am going to pass the value. Now here, while low is less than equals to high, right? This is my first condition I have put for the while. Mid, now I am, see, same that I have applied in the algorithm. I am calculating the value of mid. So here I have founding the value of mid. Now if array mid equals to x, okay, so the mid element I am comparing it, and if it is found, means I have found my desired data element, then I will return the mid. Similarly, if the value is lower, right, the mid value is, the desired data element is greater than, then low is equals to mid plus 1, else the high is equals to mid minus 1. So this is how we will do our coding for binary search algorithm. Now here the array I have specified, this array is already sorted. I have given x, I am taking a value which you want to search, then result means the particular location which will be, or the value will be returned by our binary search function. So if the result is not equals to minus 1, that means we have found our element. So I am printing this result, right? In Python we have to use this str function as we have to concatenate the two strings. So this value result is in integer form, but I am using this str function to convert it into a string value. So I am able to print this complete statement. Else, that means I have not found my element, so not found. So see, I have run this, the output you can see, enter value to search, and I have entered 6. So see, element is present at index 3. So 0, 1, 2, 3. Yes, I have got the element 6, right? So this is all about binary search. In a short, in a conclusion, I can say binary search, we can found our particular element when the list is already sorted. Second, we are dividing our list into two parts. We will compare the particular element, desired element, with the middle element, and then vice versa, we have to follow all the rules. So I hope you have understood this binary algorithm. Thank you for watching this video. Thank you so much.